okay, but we're not reading any data in because we haven't connected it up yet. We haven't connected the grabber probes up to our circuit under test. Let's do that and see what happens when we press some more buttons. So this is one we're going to use, so we want that one. How many channels have we got? Alright, cool. 8 channels on each. So I think we've got 8 channels on our LCD data bus. So we'll use all 8 channels. We won't use... So we're going to use these top 8 channels here. We won't use the lower 8 here. I think I could do with labelling these up. They're not that obvious. It's funny, it feels a bit warm, this. Actually, it feels almost hot. I wonder if that's because it's got a voltage regulator in it. I hope it isn't some tantalum's capacitors going thermonuclear on me. Let's hope not. Right, okay. This has got a calibration. Next calibration due April 92. Right, okay. Don't think we need that for now. Just push that out the way. Getting quite excited. God, any tech nerd friends who come round and see this on your shelf, they'll really think you're smart, won't they? You'll really be able to bullshit that you know what you're doing. Right, so we need. I think we want to put the. We want to connect these grabber probe channels to our data bus. And I did solder some wires on earlier just to make it a bit easier to do that. So let me just bring you in a bit and we'll attach those grabber probes. I've just noticed these grabber probes, some of them have got some little numbers on them, so that, you know, kind of like cable marker numbers. That one's just in the process of falling off. Let's put that back on before we lose it. That one says 0 on it. I wonder if some of these push-on connectors, these pin headers, I wonder if they're a standard size. I hope they are, because I haven't really got very many of these grabber probe wires. There certainly isn't enough to populate the other pod. So maybe I'll have to try and get some more of them. And I think I said before, I think from memory these grabber probes, these little grabbers, are really expensive. They just plug in. But good quality ones just cost a fortune. Right, God. You can tell I don't really do tutorial videos. I'm just letting you accompany me on the bench today. Yeah, I clearly can't give an explanation of how anything works, or, you know, it's certainly not a tutorial. We're just playing around, aren't we? Right, okay. So channel 0, we'll connect that to our least significant bit, which is this first wire here. Next one. Bit 1. Bit 2. It's actually quite tedious connecting all these up. Number 5, 6, and our final one here is 7. And at the moment I've just got one ground connection. It looks like it's possible to have multiple grounds. For every of these channel inputs there's actually a ground next to it, but I'm going to make the assumption that one ground will do for all this data bus. It's not particularly high speed or anything, and yeah, I think it'll do. So put that on there. So we've got VCC wire that we don't need, and then we've got some of those register select wires on the LCD. I I think there was a read write enable, a register select, and there was an enable line. Now I'm guessing we might use the enable line for state triggering rather than timing analysis mode. Anyway, let's see what that does. Right, so in theory we've got that plugged in. That kind of looks like a nice mess, doesn't it? We need to get some power now. Switch my power supply on. What's that set to? 12 volts, don't want to blow anything up. Looks like something's happening there. Oh, it did look like something was happening. Oh, there we go. So the LCD has turned itself on. Good. Now at the moment, the data, the characters displayed on the LCD, they're static, and I think that will mean that if we actually tried to read in, or if we was looking at the data on the on this data bus at the moment, we wouldn't see anything happening because the data won't be changing. The data only changes, or you only get activity on the data bus whenever the microprocessor is actively writing to the LCD, writing or reading from it. So we probably need to put the keypad on and put the LCD into a mode where it is going to be, changing the text on it. And I think the best thing to do is to put it in the mode where it flashes the cursor, because that will be, the microprocessor will be sending control characters to the display to make the cursor turn on and turn off. Hopefully it will anyway, but there's also, I think, a flashing mode that you can send to make the cursor flash automatically, but yeah, let's hope it's not using that mode. Too much information there, isn't there? So it looks like there's nothing in the memory of the Logic Analyzer at the moment, because we're not seeing anything. So these, just to go through it again, so it's got 0, 1, 2, 3, 4, 5, 6, 7. Those numbers there correspond to the input numbers on the data clips we've got. So that's on the first pod, which is pod A, and then these numbers 8, 9, A, B, C, D, E, F. That's the numbering for the second pod. Now we haven't got the second pod connected, so we shouldn't see any data on there. We have got the first pod. And I've just noticed at the bottom of the screen there, it says the word now. So I'm wondering if that means, is that the actual data? Is that the actual logic levels which it's displaying at the moment? I'll just bring you in, you might not be able to see what I can see. Okay, can you see the word now there? So what I think I want to do is, I want to unplug that. So which input is that? Just to test it. So channel 0, 1, 2. So channel 2 has got a 1 on it. So let me unplug channel 2 from the Logic Analyzer and see if anything happens. I'm going to unplug that. Oh yeah, and it's gone off. Can you see that? That's gone from a 1 to a 0. Let me put it back in. Ooh, come on, come out, you little bugger. Right, that's out now. I'll just dab it on and off. Hopefully you'll be able to see it. Can you see it? I'm dabbing it on. It's gone to 1, take it off, it's gone off. Dabbing it on, gone to 1, take it off. I'll put it back in again, that connection. I'll move to the next one along. I'll unplug number 3 now. He said if I can get it off. Ah, God, it's tight that. Did that go off? Yeah, it did, didn't it? Dab it on. Alright, okay. So, yeah, that's showing us a live representation of the data there. That's good, that, isn't it? Right, okay. So it looks like we've got our grabber probes connected properly. Okay. Right, let's try and grab some data now. I'm guessing what we should see is if we try and grab some data, we should see 0, 0, 1, 1 in pretty much all the memory locations. Maybe. Let's try that. Let me take you out so you can see what I'm doing. And I'm going to press the start single. Okay, so it's gone away and it's got a load of samples. Double check what rate we were sampling at. I bet you can tell me because you all saw it. Sample rate was 20 nanoseconds. Oops. So basically that, I guess that was the first sample, then 20 nanoseconds later first sample, second sample, third sample, and they all look the same. Let's have a look at it as a timing diagram. So I think we just press timing. I don't know if it'll come out very well on camera. It's actually not very easy to see. This is showing the logic levels. So this is time along this axis here. So it's like this oscilloscope screen. Bit 0 is at 0, bit 1 is at 0, bit 2 is at 1, bit 3 is at 1. And just looking at that, it isn't changing. So what does that data go up to? Well, I'm guessing that means that this is sampling up to 800. Does it go beyond that? I think if I've just pressed this right hand button, it's just moving the cursor along. I don't know how many samples this is capable of taking actually, I've got no idea. 920. Right. So this thing's capable of, looks like it's capable of recording up to 920 bits of data in memory. Doesn't seem like a huge lot, does it? But I guess memory chips and things were expensive back in the day. And those lines, they didn't change, did they? Those lines have stayed where they are. So it looks like for all those memory samples, nothing changed. And that's because, I think what we said before, because the display, the data on the display isn't being updated, so we wouldn't expect it to change. Let's go back. Rather than using that cursor button, can we press address? Will it take a number? 0. Can I put 0 in? Enter. Alright, has that taken us back? Yeah, I think it has, hasn't it? Yeah, okay. So we can either move this cursor around. Where's the cursor gone? It's disappeared. Oh, I've got to select cursor mode. Yeah, I don't quite know what I did there. No idea. I wonder what the up and down arrows do. So that moves the cursor. What does the up arrow do? The up arrow, oh, it seems to kind of expand the channels. Wonder if we can just get the 8 channels that we're interested in. Oh, go back a bit. Get 6 channels up. Oh, there we go, there's our 8 channels. So we can zoom in a little bit. We don't have to look at all 16 channels, we can just look at the 8 we're interested in. Okay, so we learnt a bit there. So we need to get this microprocessor writing to its LCD display. And I think the easiest way to do that is to make it think we're going to enter in the, the operator's code to reset it. Can I press that? All right, okay. So I've got a blinking cursor now. So I think that will mean that the microprocessor is constantly sending data to the LCD because it's making the cursor blink on and off. I wonder if we can see that in the now thing that we saw before. Ah, yes, we can. Okay, so we can see we've got our bit 1 there. It's toggling. So this time, if we press the sample button, we should see some different data appearing. The stuff associated with, I'm guessing, toggling that cursor on and off. So let's press the start button again. Start single. And the data looks to be the same there, but I suspect that could be because we are sampling very quickly, and we're probably sampling quicker. We're filling up the memory before the actual bit is toggling between one state and another because we're sampling so quickly. Let's see if we can see it in the timing diagram. No, I don't see any of those levels have changed. Let's slow the clock down. State. slower clock. Press that. Is that the right button? Oh no, press something wrong now. Let's try again. Slower clock. I think we want really quite a slow clock. Let's try 5 milliseconds. Okay, and let's make it grab some samples again. Single. Oh, right, that's interesting. Oh, that is interesting. Did you notice there that it took longer to actually, it was actually sampling for longer? That's because there was bigger gaps between the sample time. It's only got the same amount of memory. So if your clock runs quicker, you fill the memory up quicker. If your clock runs at a slower rate, your sampling period is longer. So it takes longer to do the acquisition. So yeah, that's obvious, but I just noticed that. Still haven't seen any change there. Let's have a look in the state diagram again. So the timing diagram. Ah, right, you go. Isn't that exciting? Lovely jubbly. So there we go. Our data is toggling up and down. Not that exciting though, is it? Is that all it does? I'm just moving the cursor around. I'm just trying to look more through the contents of the memory. So again, I'm all the way up to 920 samples now, and we just look to get that repetitive pattern. So I'm guessing if you actually looked at the timing on this, you would find that maybe one of them pulse times. Sorry, it'll be. That will be those gaps there will be, you know, the cursor on time and then the cursor off time. I'm guessing. Yeah, don't know, something like that. What does it look like in a different format? State. Oh, did I miss it there? There's a transition there somewhere, wasn't there? Okay. Still makes me think we are sampling quicker than we need to, because we're filling up the memory with exactly the same thing all the time. Should we slow the clock down a bit more? Let's try that. Slower clock. 10 milliseconds. So it started. Taking much longer this time to fill up the memory. Done it. Right, how do we view the data? Let's have a look at the timing diagram. Alright, okay, so yeah, we can see we've got more data there. Now it's not really very exciting, that, is it? Sending just the cursor command to make it flash. What we really want to do is try to capture some commands when the LCD is doing a load of writing. What I'm going to try and do is I'm going to try and do another set of samples while trying to make the LCD do something at the same time, because that's probably the best way to capture some data. So let's do that now. And of course, now I'm sampling, there's nothing happening. God, you little bugger. Ugh. Well, I've been trying to capture data by pressing buttons and pressing the start, and to be honest, it's all been a little bit hit and miss. But I have just noticed another thing that we can do is we can actually display the information. This is again the memory contents, and we can, before we had it selected in binary, so that was showing the individual channels, but we can also display it in, well, it looks like there's some different formats, so that's binary. There's something called SPCL, don't know what that is. Hex, well, we know what hex is. DCM, is that something decimal coding? I don't know, like binary coded decimal. Don't seem to do anything. Or we can display it in octal if you really wanted to. So well, I think binary is as good as anything. So we can see we've got a bit of activity on the data bus there. Yeah, but I'm really struggling to synchronise the grabbing the data with activity on the bus. and that's because I think this is effectively running in its in a free running clock. What we actually want to be doing is gathering data whenever the LCD is enabled, because yeah, I think basically we've just got a timing problem. So I suspect what we should do is try to change this from timing mode analysis into state analysis, remembering that state analysis is the one that uses an external clock, and I'm thinking that we can clock the data in using the enable pulse on the LCD. So I think we need to go away and figure out how to do that. So I'm going to go for an external trigger there. I think that's external trigger. I'm not sure what the minus, yeah, I don't know. I think this CQ refers to one of the inputs on one of the other pods. Yeah, this pod has got a CQ, so I think this means it's going to externally trigger using this pod, using this CQ connection. So let's have a go at that. So we are going to connect the ground wire to ground. And I'm going to connect the external clock input to our enable. Come on, get on there. It's called the LCD enable, but what I believe it's actually it's a strobe line. So basically the microprocessor puts data onto the LCD's data bus, and then it basically pulls the strobe line, it pulls this green wire here, it pulls it high, and then the LCD knows that the data is valid, and that triggers the LCD to read in the data off its bus. So in theory, and it is only in theory, when we take samples now, we should only be collecting samples, well, I believe when the enable is true. Using that external clock source really does seem to have recorded lots of lovely external data. And I've just noticed there's a function here called HMag, which, well, I think it's the same as horizontal magnification on a scope. So if I press that, we can actually zoom in on the elements of data and zoom out again. And again, what I've noticed here is when we actually stopped, I actually stopped the sampling short there because, well, because it was taking ages, because it was only recording data when there was activity on the bus. It's interesting that I think that it must start filling the memory in the Logic Analyser. It must start filling it at like the 920 mark and then work back to the beginning. So I'm guessing that, yeah, so this end, yeah, I suppose that is right. So this end is the more recent sample, this end, and as you're working back in time as you work that way, yeah, that makes sense, doesn't it? So that's the that's now effectively, and if you work back in time there, and again I'll just press that mag button so we can see, we can zoom in there. That's kind of funky, isn't it? Let's look at it in its other. Let's look at it as a state diagram rather than a timing diagram. Yeah, and you can see we're getting, yeah, every piece of data there is effectively different. So we could randomly just go through them to try to look for some characters. Yeah, maybe we should do that. I'll get the book out now for the Hitachi display, and I'll just try and decode some of these and see if it makes sense for any of the words that I recognise on the display. Might take a bit of time, but let's have a go at that. At the moment, this alarm is displaying the word Northern Alarms on it, and I think I was capturing data when it put that message up on the display. So I was hoping that I would have all the data to show the N and the O and the R and the T and the H, you know, etc., etc., to make up the word Northern Alarms. And I've had a manual look through the data table just by scrolling through and trying to do the conversions for various letters, and yeah, it's not really got me very far. But there is an automatic search function on here that I've just discovered, and again I'm still not sure it's getting me where I want to be, but we could just show you that because I did think it was quite interesting. So in the case of the letter N, the first lower bits are 0, 1, 1, 1. So if you go to the main menu on here, there is this search word that we can set up. So let's just go down to that. And I said, doing it the wrong way round, it's 110, 1, 1, 1, 0. And then we've got to set up the higher 8 bits, which again, just going back to this sheet and go up there, I'm looking for 0100. So 0100. Okay, so we've set up a search criteria now. So if we go back to the state diagram and I press the search button, it's going to go all through all 900 memory locations looking for this letter N. So how do I do that? I press search, don't I? Where's it gone? There, N, search. And so it's come up with the letter N in locations 262 and also 263. And we will have a scroll through. And in fact, maybe that's the only occurrence of it. So it's just found that N character. Oh no, it has found it more than that. Oh, it's found it in a few places. Okay, not very good. Let's try again. Maybe I'm just not paging through very effectively. So there's none of the N characters on the first page. We've got it appeared to occur twice here at register location. At memory locations 262 and 263. Then it appeared again at 476 and 477. Then at 624 and 625. Then at 964 and also 965. Yeah, but when I was actually putting the data in, I don't think I actually got that many N's in there. And also, that means to have the N's in the two registers next to each other. For example, those two memory locations 964 and 965. I think that means that they would have had to have been a double N printed onto the screen, and I'm not aware we have had a double N printed onto the LC display screen. So I think there's maybe something not quite right with my setup because I don't appear to be getting the correct data displayed, and I guess this is part of the art of using a logic analyzer, in that they're a little bit complicated and you probably need to build up a little bit of experience of how the piece of equipment works before you just jump in. And I've kind of jumped in at the deep end with both feet, as I normally do. And to be honest, that's the way I prefer to do it. Like I said, reading manuals is the last resort. But I actually did have a go at reading the manual, and it didn't get me an awful lot forward because, it was assuming that the person reading the manual was an expert in logic analyzers, which I'm not. So half the stuff I read I didn't understand anyway. But yeah, I think it's a matter of small steps, and I could perhaps do with trying to find a way of writing some data that's a little bit more predictable, because at the moment I'm not exactly sure the sequence of how this LCD writes, and yeah, I'm also wondering if I've just got something set up wrong with the external clock. As far as I know, I have got it set right. It's got this external minus and plus, and at first I assumed that was to do with, again, a rising or falling edge, but I found out when I have external plus there, it never seems to sample at all. And then we've also got this where it says minus CQ here? Well, I'm fairly sure CQ is the clock input that it's talking about, and that can also be set to be a plus or a minus. And I tried it set to minus, and I've also had it set to plus, and again, I'm not really seeing that it made any difference, because I don't know what a good set of data would actually look like. So yeah, I'm struggling a bit at the moment, but it's been really interesting. Certainly one of the more complicated pieces of test gear. You know, I'd probably put this on a par with something like a vector network analyzer, something like that. It's certainly not easy to use, and you know, there's an awful lot of traps to fall into. And I think probably what you need to do, as I said earlier, I think perhaps you need to understand how the instrument works before you actually try and use it, and that's where I'm falling down a bit. But yeah, it's kept me occupied for the day. 20 quid well spent. If you've got any comments or you've got some helpful advice, always appreciated. But I think that for now, that'll do. So thanks for watching, everybody, and I hope to see you again soon. Bye bye for now.